In this video, we are going to solve a few systems by using the method known as elimination. The first system that we will solve will be x plus y is equal to 7, and the second equation will be x minus y is equal to 5. We'll call this one equation 1 and this one equation 2. Now, when you solve a system using elimination, the big picture that you need to keep in mind is that we are going to add equations. We're going to add these equations up in the hopes of getting one variable to drop out of the system after we add the two equations. If we can get one variable to drop out of the system, we'll only have one variable left to solve for, and I'm confident that you can do that. Let's see what happens when we add up these equations. X plus another x. I've got two x's now. A positive y plus a negative y. Wow, look at that. The y's just went to 0. And on the other side of the equation, 7 plus 5 is 12. This is what we wanted to have happen. We added these two equations up, and in the process, the y's dropped out of the system. So, now we can easily solve for x. We'll divide by 2. Looks like x is equal to 6. Are we done? No, you say. You only know what x is equal to. Good answer. Let's go ahead and now solve for y. The good news is, now that you know that x is equal to 6, you can plug into the x variable in either the first equation or the second equation. It doesn't matter which. You choose. I think I will go with the first. No real reason. If x is equal to 6, let's go ahead and plug a 6 right there into the x. So we're going over here now. 6 plus y is equal to 7. I'll go ahead and subtract 6 from both sides. Looks like y is equal to 1. And there you have it. The solution to this system, x is 6 and y is 1. Okay, so that was a pretty basic, good starting point for learning how to solve systems using elimination. Let's go ahead and do another one. This time we'll get a couple of different variables involved. A plus 6b is equal to 2, and a plus 3b is equal to -1. Now, I've already said that your goal is to add these two equations up in the hopes of getting a variable to drop out. Let's see what happens when we just add these two equations up as they are. A plus A, you got 2 A's. 6B plus 3 more B's, you got 9 B's. And on the other side, you've got 1. That didn't help at all. You still have two variables to contend with, and so what we're going to do, we're going to do a move so that when we do add both equations up, we're going to force one variable to drop out. Now, using your imagination, can you imagine if instead of A, if this were a negative A, can you see how 1A plus a negative A would cause the A variable to drop out? Absolutely. So let's force it to become negative a. I'm going to multiply both sides of the equation by -1. So if we do that, of course, equation 1 will not change. That remains a plus 6b is equal to 2. But equation 2 is now, okay, that's negative a. -1 times 3b is now negative 3b. And -1 times -1 is a positive 1. So this is what our system now looks like. Now, when I add up both equations, positive a plus a negative a, the a's just dropped out, and that is exactly what we wanted. 6b plus a negative 3b, there's 3b, equals to 3. Look at that. Only one variable left, and we're now going to solve. Divide both sides by 3, and we see that b is equal to 1. We're going to use that fact to go back and figure out what a is equal to. Now, I want you to pause the video if you feel that you can use b to go back and solve for a. I'll give you a head start, and then get the video going again, and I'll compare my answer to yours. So b is equal to 1. Let's plug into the first equation. Sure, we could have plugged into the second equation as it originally was, but because it didn't matter, let's just plug into equation 1. So that means a plus 6 times b, we said b is 1, that's equal to 2. All right, let's solve here. I'll subtract 6 from both sides. That leaves me with a being -4. So a is -4, and b is equal to 1. And notice how I reported my answer in alphabetical order. Make sure you do the same. Okay, so that's how we solve that system using the elimination method. Let me give you one more. And remember, at any point in this video, if you think you can get to the finish line without using my assistance, just pause the video, solve it on your own, and then get the video going and compare what I do to what you did. Okay, so here's our new system. We've got 3r minus t equals 7. Then we also have 2r minus t is equal to 2. Okay, so the first question I would ask you is, if we add these two equations up as they stand, will a variable drop out? I hope you said no. 3r's plus 2r's would give you 5r's. Negative t minus or plus another negative t is going to give you negative 2t. And that's 9. And look at that. We still have both variables to contend with. So we need to do a move. Now I'm hoping that you can see, just using a little imagination, that if instead of this being a negative t, what if this were positive? Then when you do add both equations up, you could say negative 1t plus 1t, and you would have no more t's. let's force this to become a positive 1t. How do I do that? By multiplying this entire left side of the equation by a negative 1. Also, let's do the other side by negative 1. I'm doing this just to force this to become the positive t that I need. Okay, so let's rewrite the system. The first equation does not change. It's still 3r minus t equals 7. The second equation, however, now becomes negative 2r. Negative 1 times negative t. There's my positive t. And that's equal to a negative 2 over on the right side of the equation. Okay, so let's add these two equations up. If we do that, 3r plus a negative 2r, that leaves you with just an r. Negative 1t plus 1t, no more t's. And 7 plus a negative 2 is just 5. And wow, look at that. The answer just jumped right out at us. R is equal to 5. Let's use that value for R and go back so we can figure out what t is equal to. I'm going to go ahead and plug this R value of 5 right there. So when I rewrite that first equation, I will have 3, instead of R, I'll put my 5 in there, minus t is equal to 7. So there's 15 minus t equals 7. Subtract 15 from both sides. That leaves me with negative t is equal to negative 8. And because this is a negative 1, I'll divide by negative 1. And now t is equal to a positive 8. All right, so my answer, R is equal to 5, and t is equal to 8. And if you're wondering, how do I check this? Put these two values into your two variables, here and here, and when you do that, this should all equal 7, and this should equal 2. Okay, that's it. I hope that these examples help you in learning how to use elimination as a method for solving a system.